Okay, this video is about simplifying complex fractions. As you can see, all of the fractions that I have on the board, they look really complicated. It's a fraction over a fraction, which is called a complex fraction. When you're asked to simplify a complex fraction, your job is to calm it down, put it in a different form until it's just a regular fraction. Notice that there's no equations involved. There's no equal sign. So the idea of multiplying both sides of the equation by the same number does not apply here because we do not have an equal sign. So we have to do the best we can. So this is number one. These are different types of complex fractions, and so when you're presented with one like this is what I call a nice and tight complex fraction. It is this basically, A over B divided by C over D. This is what I call a nice and tight, as opposed to any of the others. These are not in that same sort of structure, because you see these subtraction signs, these addition symbols. This is not simply a fraction over a fraction. These are not nice and tight, but number one is. If you're presented with one like this is a fraction divided by a fraction. If I wrote that in a different way, this is equal to a fraction divided by another fraction. Well, if you have a fraction divided by a fraction, this is you keep, change the operation of multiplication, and you flip. Take the reciprocal of the second, and then you're just multiplying fractions. So if I'm presented with a nice and tight one, which I am, I will simply keep the numerator, 5x over 27, change the operation to multiplication and take the reciprocal, multiply it by the reciprocal, negative 21 over 10xy. And then I'm just multiplying fractions. The rule when you're multiplying, everybody's being multiplied, is if you see a cancellation you can make in the numerator with the denominator, go ahead and have at it. This x can divide into this x one time. There's a 3 and a 21, it goes 7 times. There's a 3 and a 27, it goes 9 times. I see 5 can go into 10 2 times, and I think that's it. So now I have 1 times 7 times a negative gives me negative 7 over 9 times 2 times 1 times y. 9 times 2 is 18, times 1 is 18, times y is 18y. So you can write the negative in the numerator, in the denominator, or in the middle, and it means exactly the same thing. So that's number one. Now, we have to ask ourselves, what should we do if we're presented with one that is not nice and tight? You have two options here. One is to make it nice and tight. Get a common denominator in the numerator between 7 and 5, and change the numerators and add that till it's one fraction in the numerator. Get a common denominator down here, add that together till it's one numerator. So we could do that. Let's see, what would be the lowest common denominator here? 35. So if I change this to be a 35 plus a 35, okay, that's the numerator. I'm only looking at the numerator. I said 5 times what gives me 35? Times 7. 3 times 7 gives me 21. Okay. 7 times what gave me 35? Times 5. So this is times 5. This will be a 10. Now this could be thought of as 21 plus 10 is a 31 over 35. That's what we did with the numerator. Let's look at the denominator. What would be the lowest common denominator between 5 and 6? It would be 30. So let's change this. This is going to turn into a 30. How do we do that? We said times 6 times 6. 6 times 1 is a 6. Let's change this to a 30. How do we do that? We said 6 times 5 times 5, 25 over 30. Now we can combine these fractions, add the numerators, keep the same denominator. 25 plus 6 is 31 over 30. Now, I've made this into a nice and tight fraction, so now I can keep, change, flip it. So this will be 31 over 35 times 30 over 31. Now we can cancel anything we see in the numerator and denominator. 31 goes into 31 one time. Let's see, 30 and 35. It's got some 5s in there. 5 will go into 30 6 times. 5 will go into 35 7 times. So 1 times 6 is 6. 1 times 7 is 7. This is the simplified form of that complex fraction. All right, so that's the first two. Let's do a couple more. I'm going to let's look at number 3. Here is a different method. I'm going to choose to do number 3 and number 4 differently than I did 2. This is the second option that you have. When you have a complex fraction, that is not nice and tight. Another way you can approach this, instead of getting common denominators and doing keep, change, flip, is just find the common denominator between all the little denominators. So let's find that. So when I look at this, the little denominators, it's just this, y and y. What's the lowest common denominator between y and y? It's just going to be y. So I'm going to say, okay, y is my lowest common denominator. After I make that decision, what do I do with it? Well, I multiply this big numerator and this big denominator by what I think the lowest common denominator is, y. I'm going to multiply it by y. But it's going to distribute to both terms, right? When I do that. So what I get here is 3 times y, or 3y, minus 1 over y. And if I want to, like, if it distributes and I want to write it down so I can see it distribute, that's fine. 3 times y is 3y, minus y over 1 times 1 over y is 1 over. 2 times y is 2y, minus 1 over y times y over 1 gives me a 1, because these will cancel, right? And so this is the answer. That's the simplified form of that. Okay, I'm going to choose that method again to simplify number 4. Number 4 is 6 over x plus 3 over xy over 2 over x squared y plus 3. Okay, what are all the little denominators that we see? X, xy, x squared y. What is the lowest common denominator we can come up with for that? Let's see, the lowest common denominator. I'm going to need an x, definitely. X can go into x. Can xy go into that? No, I need to build it on. I need to build on a y. X can go into that. X times y can go into that. Okay, down here. Can x squared times y go into that? No, I need another x. I need to multiply it by another x, or x squared. Let's see, I think that will do. X can divide into that. X times y can divide into that. X squared y can divide into that. And this 3, if you want to see his denominator, it's really a 1. 1 can go into that. So what do I choose to do after I find the lowest common denominator? I multiply the big numerator and the big denominator by what I think it is. I'm going to multiply the big numerator by x squared y. And I'm going to multiply the big denominator by x squared y. I'm going to write it on both sides because it's going to distribute to both terms. Okay, so right here. X squared y over 1 times 6 over x. What will cancel? One of these x's will cancel out. So I'm left with 6 times x times y over 1, or just 6xy. Here's the plus sign, plus 3 over xy times x squared y over 1. What will cancel? The y will cancel, and 1 of the x's will cancel. I'm left with just, these are 1s, 3 times x times 1, or just 3x, over 2 divided by x squared y times x squared y over 1. What will cancel? X squared y will cancel with each other. I'm left with 1 times 2 over 1. I'm left with the number 2 right here, plus 3 over 1 times x squared y over 1. Nothing cancels because there's only 1's in the denominator, plus 3x squared y. This is the simplified form of that complex fraction.